Good afternoon, students. So let us start with today's class. Yesterday we have discussed that is Einstein's explanation for photoelectric effect, right? So what is the Einstein explanation for photoelectric effect? We have a formula which will give you. So here what Einstein will say here, whatever the radiation light is there, it behaves as a what photon. Light behaves as a photon. It is having energy h into nu. That right? So your photon is having energy h into mu. This energy is distributed in two forms. So or divided into two parts here. So one part is used as what? As a work function. One part is used as what? Work function. So that is given by what? Pi naught plus. The other half is used for what? As a kinetic energy. Means the electron requires some energy to move from the anode to the cathode. Here whatever the energy is required, that is nothing but for kinetic energy. So that energy is given by the light radiation which is having value h into mu. So half part is used as work function. This work function is nothing but the minimum energy required to come out from that surface barrier. Then half portion is used for what? Kinetic energy. Okay, so this is Einstein's explanation for photoelectric effect. So today we are going to discuss photoelectric cell. So what do you mean by photoelectric cell? As the name indicates, what do you mean by photoelectric cell here? As the name indicates, photo means what? It is light. Electrical energy. So the conversion of light energy into electrical energy, the device which converts light energy into electrical energy, such a device is known as what? Photoelectric cell. What do you mean by photoelectric cell? It is a device which converts light energy into electrical energy, that is known as photoelectric cell. Is it clear? What do you mean by photoelectric cell? What are the uses and what is the working of this photoelectric cell that we will see? So roughly I draw the figure. Okay, I'm not good at drawing, so just roughly I'll draw this. So this is your incident light, and here is the ammeter, cathode. This is anode. Okay, so this is somewhat your photoelectric cell looks like. What do you have here? You have a cathode plate, anode is there. So this anode is a collector, cathode is an ammeter. Cathode acts as ammeter and anode acts as collector here. Here the incident light radiations are falling on. Incident light radiations are falling on the cathode plate, which is the ammeter. So this is externally connected to the battery, rheostat and ammeter. Why we have ammeter here? As you know that photoelectric cell is a device which converts electric light energy into electrical energy. So convert करके जो current मिलता है आपको that you can measure by what? Microammeter, right? So we have a device microammeter which measures this electric current. Okay. So here what happens when light radiations are incidenting on your cathode plate, the whatever your external source is there, that will help the electrons which is coming out of this surface, it will reach the ammeter. So that is anode plate, which is a collector, photocell, and one thing to remember, by this photoelectric cell, whatever amount of current you are getting, that is very small amount, that's very small amount. Therefore, we are using here microammeter. Therefore, we are using here microammeter. This microammeter will help you to detect the small amount of current which is there in the circuit. Are you getting? So by this you can do some electrical whatever necessary is there. For examples, for small purposes you can use this photoelectric cells here. So what are the uses? Let us see. So the first use of the photoelectric cell is, first use of photoelectric cell. It is used in switching on or off of the street light. It is used in the switching on and off of the street lights automatically. So in some of the places they are using this photoelectric cell. So automatically means when light radiations will fall on it, so it is used as what? Switching on and off of the street lights. Okay, so actually it will trap those radiations. So if you switch on that circuit in the evening or in the night time, whenever you require, you can use it. So that is what switching on and off of the street light. There also you are using photoelectric cell. Then the second application, it is used in the burglar alarm. So it is used in the burglar alarm, which is this, or in the fire alarm. So in the fire alarm also they are using the photoelectric cell. Then a third application is, it is used in TV camera. So it is used in the TV camera, which will convert light energy into what? Electrical energy. So the photocells are used in switching on and off of the street lights. This is 2 marks question. It is used in the burglar alarm. It is used in the TV camera. Then the fourth application is, it is also used in the industry to locate the flaws in the metals. It is used in the industry to locate the flaws in the metallic whatever sheets you have or metallic bodies you have. So there we are using this photoelectric cell. Okay, so this photoelectric cell is used in the industry to locate, मतलब detect करने के लिए, क्या detect कर रहे हो? Flaws means what? It is defect. So where the defect is there in the given metallic sheet, that you can identify by using your, that is photoelectric cell. And the last application of photoelectric cell is, it is used in the measure of temperature. So it is used in the measure of temperature in the stars. It is used in the measure of temperature in the stars. So these are the 5 uses of what? That is photoelectric cell. Are you getting my point? What do you mean by photoelectric cell? How the construction is there working? Then we have uses. So this is 2 marks uses will be asked. So if the working of photoelectric cell is there, then it will come for 3 marks. Are you getting my point? So this is regarding the photoelectric cell. Is it clear? Very simple concept it is. Okay. So the next concept we will see, that is wave nature of matter. Next we are going to discuss, that is wave nature of matter. So what is this wave nature of matter? Wave nature of matter is this. Now you already know that, that is whatever your light is there, it is in the form of what? What Einstein will say, it is in the form of photon. Okay, it behaves as radiation as well as it behaves as a photon also. Photon is nothing but what? Photon is nothing but, it is like a particle nature. Are you getting? Photon means what here? Photon is something which has both energy and momentum. Which has both energy and momentum. When a मगर आइंस्टीन क्या बोलता है, इट इज नॉट photon, that is light energies are what, it is the discrete form of energy, that is nothing but the photon here. So the photons are having energy as well as momentum. When they have both energy and momentum, it behaves as a particle. So in the same way, De Broglie, what he will suggest, that is wave nature of matter, means moving matter behaves as both, that is particle nature as well as wave nature. So what De Broglie will suggest? De Broglie will suggest that is the matter behaves as both, that is particle and wave nature. So the moving matter behaves as both, that is wave like, and what one more is particle. It behaves as both wave and particle nature. So this is what De Broglie explanation. De Broglie suggests that your moving matter behaves as both as wave and particle nature. So we have proof also for this in 1927. Davison and Germer, in the 1927, Davison and Germer will give an idea. What they will give idea, that is this moving matter behaves as both wave nature as well as particle nature. That experiment is also there for your syllabus, but whatever updated news or the updated syllabus is there for this academic year, they have removed Davison and Germer experiment. Okay, so far it is removed, but we will see again if they add later, then again we will come to that explanation part. But as for now it is deleted, so I am not going to teach that Davison and Germer experiment. Actually it is there in the textbook also. So in 1927, Davison and Germer will give proof that is your matter behaves as both wave-like and particle-like nature. So what is this De Broglie hypothesis? Let us discuss. So next concept is De Broglie hypothesis. So what is your De Broglie hypothesis here? According to De Broglie, a moving particle sometimes behaves as a moving matter behaves as particle as well as wave. That is only De Broglie hypothesis. Okay. So what is De Broglie will say? Moving particle behaves as a particle when it is interacting with matter. When the interaction of matter with, so here interaction with matter is there, then it behaves as what? Particle. When it is propagating in space, then it behaves as what? Then it behaves as a wave-like nature. So when particle is interacting with the matter, it behaves as particle. The moving particle behaves as a particle when it is interacting with what? Matter. Okay, and it behaves like a wave. When it behaves like a wave, when it is propagating through space here, when it is propagating through space, it behaves as a wave-like nature. Okay, are you getting my point? What we are saying? That is your moving matter behaves as both particle nature as well as wave nature. When it behaves as a particle nature, when it is interacting with the matter, that it behaves as particle nature. When it is moving in a free space, that time it is possessing the property of what? Wave nature. So this is called as what? De Broglie hypothesis. This is called as De Broglie hypothesis. So according to Planck, what is our equation? Our equation is E is equal to H into mu. This is our Planck's equation. E is equal to H into mu, where H is the Planck's constant, mu is the frequency. According to Einstein, we have E is equal to what? mc square. Right? According to Planck, it is E is equal to H mu. Einstein, it is E is equal to mc square, right? Now you can equate equation 1 and equation 2. So after equating equation 1 and equation 2, you will get it as h nu is equal to what? Mc. You will get it as h nu is equal to mc square. Therefore, what you can write here? You can write it as, I'll write it as mc is equal to h nu divided by c. Check the steps. What I did here, we have c square. So instead of writing mc square, I write it as mc which is equal to h nu divided by c. इधर का जो c square है उसको मैंने स्प्लिट किया है c into c. c इधर नीचे लो, ये क्या होता है h nu divided by c होता है. Is it right? So this is one point. So here you have h nu divided by c is equal to m into c. Okay. So now what is this mu divided by c? Have you studied ever? What is mu divided by c? I don't think you have that idea. So this mu divided by c is nothing but, because mu divided by c we can write it as 1 divided by lambda, means the ratio of frequency to the velocity of light is nothing but reciprocal of what? That is wavelength. अभी इसका 1 divided by lambda वैल्यू इधर सब्स्टिट्यूट करो, क्या होता है देखो, बिकम h divided by lambda is equal to what? m into c. Therefore, you can write lambda is equal to, what you can write lambda is equal to? Lambda is equal to becomes h divided by m into. So this is as de Broglie wavelength. This is as de Broglie wavelength. So they will ask you question, what is the expression for de Broglie wavelength? Or 2 marks critical will be asked based on this point, that is lambda is equal to h divided by m into c. Okay, so this is when it is propagating in a space. When it is propagating in a space, you will get it as h divided by mc. If it is in the medium, then instead of c, you will take as v. Is it right? So what we have done, see, we have E is equal to h into nu according to Planck. E is equal to m into c square according to Einstein. We just equated equation 1 and 2. So after equating equation 1 and 2, you will get it as h nu is equal to mc square. That is h nu divided by c is equal to m into c. Right? So just I split it and I have written it like this. Next you see, mu divided by c is nothing but what? 1 divided by lambda. Therefore h by lambda is equal to what? It is m into c. Therefore this entire term I can rearrange it as what? Lambda is equal to h divided by c. Can anybody tell me, if I replace c by v, means if I write it as lambda is equal to what? So that is lambda is equal to h divided by m into v square. And what is this v? M into v is called as, what is the product of mass and velocity is known as? What is the product of mass and velocity is called as? What is mv? What is m into v is called as? It is, किसी को भी पता नहीं? कुसुमा, ऐश्वर्या, सना, रुद्रया, लक्ष्मी. What is mv? Mass into velocity is known as? It is nothing but momentum. It is nothing but momentum here. Therefore, lambda is equal to, I can write it as h divided by momentum v. So this is your de Broglie equation. This is called as what? De Broglie wave equation. So what I did, E is equal to h nu, E is equal to mc square. Equate both the equation and simplify. So after simplification, you will get it as what? Lambda is equal to h divided by mc. So that is nothing but lambda is equal to h divided by p, where p is known as what? Momentum of the particle. Momentum of the particle. Is it clear? So in exam, they may ask you, what is de Broglie hypothesis? Derive an expression for de momentum. Right? So this is de Broglie equation. Do you have any doubt in this? Okay, then the last point in this chapter is, so the last concept of this chapter we are going to discuss de Broglie wavelength as an electron. De Broglie wavelength as an electron. So how we are going to prove de Broglie wavelength as an electron? That is, see, consider that electron is moving with a velocity v. Consider an electron which is moving with a velocity v when it is given by a potential of capital. Okay, capital V is potential, v is velocity of the electron having mass m, charge e. Right? So work done on the electron is given by, so work done on the electron is given by E into V. That is given by E into V here. So E is charge of electron, V is potential here. V is potential. So kinetic energy is given by, what is kinetic energy? It is half m v square. It is half m v square, right? So what you can write here? You can write this equation as, that is, see, I'll write one step whether you will understand or you will just take. So I'll write it as half m v square is equal to, I'll write it half m v square is equal to p square divided by 2m. I'll write it as half m v square is equal to p square divided by 2m. How did I write this? How the step will come? Shall I explain? See here, we have momentum is equal to, mass into velocity. We have momentum is equal to mass into velocity. Right? So therefore velocity is equal to what I can? I can write it as p divided by m. So we have momentum is equal to mass into velocity. Velocity is equal to momentum divided by mass. So substitute here. V का वैल्यू क्या है देखो आपका, V का वैल्यू आपको क्या मिला, p डिवाइडेड बाय m मिला, इधर मैंने वो सब्स्टिट्यूट किया. So that is p square divided by 2m square होता है, m कैंसिल होके इधर m. Is it clear? This step is clear to everyone? Is it clear, students? So here you will get it as, that is p square divided by 2m. We have lambda is equal to h divided by p according to de Broglie equation. According to de Broglie equation, we have lambda is equal to h divided by p. Now, from this equation, p is equal to क्या मिलता है देखो. So this entire term is nothing but what? Kinetic energy. Therefore, here I can write it as kinetic energy is equal to p square divided by 2m. Okay. So that is kinetic energy is equal to p square divided by 2m, which implies p is equal to under root of 2m into kinetic energy. Alright, kinetic energy as p. So I'll substitute the value of p here, h divided by under root of 2m into p. So this is the expression for lambda in terms of kinetic energy. This is the expression for de Broglie wavelength in terms of kinetic energy.